Okay. Okay. First question is the question for the third speaker. What is the required temperature during the operation of AMIM? Nirutsu-san?
Yeah, so the temperature, we can operate over a wide variety of temperatures, actually. So we've designed the instrument to be able to operate both in kind of the polar environment, but also sort of the equatorial. Maybe there's a limit to sort of the lunar noon, right? We can't go really as high as 100 degrees, right? Because the infrared is too high, right? And so the electronics, but I think we can get up to 70 degrees Celsius. But then on the colder end, we can get down pretty cold. We have, with a little bit of heaters, right, we can get down to about like 100 Kelvin.
Thank you.
This is Dave. I'll take the question about the dust. Considerations for windows and cameras to be protected from dust. Certainly for a long duration mission like the pressurized rover, it could be 10 years. It would be prudent to incorporate something like a reclosable door to protect the optics, or the instrument might be able to rotate to a stowed position, essentially inside its housing, to close everything up and protect it while the rover is in motion. So yeah, there will be some engineering needed to protect from dust, either dust that's levitated naturally or that potentially could be stirred up by the rover, or certainly astronaut activities as they're walking around. Thanks.
Like there's a question to Jorge. Could you clarify how your system adjusts wavelength or focus? Is this done autonomously, dynamically, or through a combination of both?
Yeah, those are great questions. Yeah, so the way your instrument works is it literally is kind of like flash photography. Just kind of like, we've seen those sort of professional photographers where it kind of, takes flash images. And so it's the way we do it. We build our image cube is basically take images of different wavelengths, and it's kind of in a sequence, and that's how we build our image stack. But of course, because we have a really fast frame rate with our camera, it takes we can acquire a full image cube within just a matter of a couple of minutes. And yes, it's done kind of sort of autonomously, right, with scripts. As far as the focus, yeah, so it would be kind of has a sort of autofocus, right, so that it identifies your sort of best focus position, but then we have the ability to kind of step the focus over sort of different images. And so most likely what we would do is, you acquire your image at sort of the lowest kind of position, and then, your sequence, and then sort of move the steps to the next position of focus, right? Maybe towards the upper end, and do another sequence. And so then you can sort of do Z stacking for each sort of band, right? And then of course results in a fully sort of in focus for the full frame, especially if you have topography. Okay, I guess there's another question for me. Okay, the power density of the surface. Yeah, that's a really good question. So these are, they're bright, but they're not super powerful. I mean, these are kind of low power LEDs, and so we haven't really we haven't done the tests yet because we're still kind of in the process of doing testing. But I don't think that it would be kind of a concern that we're going to sort of be heating up the surface, right? And again, because we're sort of, these are very short exposures, right? We're not really sort of like standing there and illuminating the surface for long periods of time. It's actually very, we're talking about millisecond exposures. And so even for like a single wavelength, you're talking about less than a second or so per wavelength. So then it's within just kind of a few, at most maybe a couple of minutes or so as you're kind of cycling through. But yeah, that's a good question, and I think that's probably a future test that we'll try to sort of keep an eye out for.
There's another question in there for you.
Yes, great question. That's something actually that we've kind of looked at. And, obviously, we have done straight light analysis, and that is kind of a concern, especially whether you have sort of ambient light that's coming in, or if you have illumination from the LEDs, right, that is kind of reflecting. And so we've done, and we actually have kind of like a little internal baffle that allows us to make sure that we don't have any sort of stray light coming in, that goes into the optics. But yeah, it's a great question, and that's something we kind of looked into.
There's also a question about the observation plan. Did you catch that one? Or
oh, sorry, which one?
Yeah, maybe it was
observation plan.
Yeah, the timeline. Yeah, routine or
okay, yeah. So we designed the instrument so that it's actually like I mentioned, right, to acquire images, to get through an image set, right, or image cube, doesn't take a lot of time, right? Because if you think, for example, like Endurance A, right, the type of rover, right, where it's going to have to traverse a lot of time, you can't sort of stay in one spot too long to do an investigation. And so that's kind of how we designed the instrument. So it can quickly acquire images, data that then can be returned. And of course, because you don't have to acquire a full image cube every time, right? There's different sort of modes of operation where we're kind of in prospecting mode where you can just do maybe a few bands, right? And that's even shortened the amount of time in terms of position. If you're just kind of trying to get a quick and dirty sense of like spectral diversity that's on the surface. One of the other things I think maybe just related to that is we're developing, because at APL, right, they help develop mice, and so we're leveraging some of the experience from development of mice, which is an imaging spectrometer that's on the Rover Clipper, and of course, data volume, right, with any type of imaging spectrometer, data volume is kind of a concern, right? You're not going to be able to send all those images back, right? And so we're developing sort of this onboard processing where the image kind of sort of generates sort of these quick look type of products, right? And so we have team members who we developed CRISM instrument also on Mars. And so we're leveraging their sort of the pipeline that they developed to generate these types of quick look products, right? Where it's kind of targeting sort of like those images that I showed, right? When it's sort of visible in near IR, just to give you a sense of quick diversity, but also if you're looking at for like iron mineralogy, or if you're looking at for hydration, right, that can generate, and so send that down instead of having to send the full image. Anyway, thank you.
And the next question is to Nakauchi-san. So, how large is the depth of the field of this NR camera?
Yes, thank you for your question. So the depth is a few hundred micrometer to the few millimeter, but we can so very narrow region, but we can this camera on board the autofocus system. It was demonstrated by the 3 mission. So so we can do focusing from the 5 centimeter to the 7 centimeter. So yeah, so we can choose we can adjust the focus this working distance range. Yeah, thank you.
Thank you.
I think there's a question there for me about the color information with the mosaic filter. I think just under the standard operation, we would work, you know, just the way a bare RGB camera does, right? You just take your snapshot, and of course, there's some penalty in spatial resolution associated with the filters in the pattern. So yeah, we're not planning to do any you know, shifting of the field of view to line up the pixels or anything like that. It'd just be the typical interpolation techniques that are widely applied to bare pattern cameras. And let's see, another one. Do I need pointing capability with the camera, or can a fixed position accomplish much of what you would want? Well, it would be great to point. As I mentioned, I think we would probably want at least a 1 degree degree of freedom pivot so that the camera can point to you know, whatever is in the surroundings. We probably don't need to pivot up too much. You know, the field of view and mounting angle can be designed so that you've got, you know, a little bit of the sky, and then, you know, the ground in the foreground in the scene. So I think a 1 degree pivot would do the job.
Okay. Thanks everyone, all the speakers, and great questions